Now let's discuss in detail about the flux. And flux is only there for GEE NEET. First, we are going to discuss the acidic flux. So acidic flux is used to remove basic impurities, let's understand by taking one example, such as you have a calcium oxide as a basic impurity. So you have to use acidic flux such as silicon dioxide. This is acidic in nature and here it acts as a flux. And there is formation of calcium silicate, CaSiO3, calcium silicate slag. Okay? Or you can remove the slag easily. So there are some metal oxides which can be used as acidic flux. Sorry, non-metal oxides which can be used as acidic flux, such as SiO2 and P2O5. Listen, non-metals are acidic and non-metal oxides are also acidic. So with a basic impurity, if you add an acidic flux, there is formation of a slag. Similarly here, basic flux is used to remove acidic impurities, same example we can take, but here calcium oxide will act as a basic flux and SiO2 is here acidic impurity, and there is formation of calcium silicate as a slag. Okay, so to remove acidic impurity we need a basic flux, and to remove basic impurity we need a acidic flux. Here metals are basic, that's why their oxides are also basic in nature. So some other example of metal oxide which acts as a basic flux are calcium oxide, that already we have used, and another one is magnesium oxide. Okay, and the third category is neutral flux. So here we first understand the definition of this. Substance used in electrolytic reduction to decrease the fusion temperature and to increase the conductivity of the solution by providing free ions. Examples are nothing but cryolite, Na3AlF6 and a feldspar. And the third one is calcium chloride. Generally this is used in a mixture. I mean this is used both together. Okay, so where we are using this mixture, definitely it is used in the process of Hall-Héroult that we will discuss in detail. But sometimes what happens, in electrolytic cell there is electrolytic solution, but it should be melt. Fusion means what? The solid should be converted into liquid or a molten state. So the melting point is too high that we cannot convert into molten or liquid state. In this situation, we have to use a neutral flux which reduces its temperature and makes it convert or fuse into a molten state. Once it converts into molten state, it can gives a free ions. So there will be a better conduction of electricity. Now the next topic is smelting in Cu metallurgy. Means for the extraction of copper, how smelting process is used. So while extracting a copper, its mineral is available in this form, mixture of CuS and a FeS. Once by the roasting, we can convert this to Cu2O and we can convert this to Fu. Afterwards, plus coke and a flux, there is formation of Cu2S and FeS, and this mixture is said to be a metic. And there is formation of slag due to addition of this flux. Afterwards, this Cu2O reacts with FeS and there is formation of Cu2S plus FeO. So now your whole substance is converted into this mixture. Now you don't require FeO. So by adding this flux, FeO can be converted into iron silicate, that is FeSiO3, and you can easily remove this slag. Now you have only Cu2S. So with the self-reduction process, you can remove this impurity. Okay, that we will discuss in detail. Let's discuss some other examples. PbO plus carbon, Pb plus CO, SnO2 plus carbon, Sn plus twice CO, Fe2O3 plus carbon, twice Fe plus 3 CO. This is carried out at high temperature. Fe2O3 plus 3 CO gives twice Fe plus 3 CO2. PbO plus CO gives you Pb plus CO. SnO2 plus twice CO gives you Sn plus twice CO2. And this will be carried out at low temperature. So now you are clear that at high temperature, we are using a carbon as a reducing agent, and there will be formation of carbon monoxide as a volatile gas.